So now let's talk about some of the basics of the Python syntax. So the first thing we'll talk about here is comments, variables, and variable types. So there's various ways that you can define variables in Python, and actually it's pretty easy. So if we look at this format right here, I can say int val equals 8. And what that does is it actually creates a variable called int underscore val, that's the variable name, and assigns it with the value of 8. Right? Now you'll notice I did not declare this variable at all, which you would have to do in say Java, C, C++, most other programming languages. You need to actually tell it what type this is explicitly. In Python, it infers the type of the variable based on the first assignment that you give it. So when I say int underscore val equals 8, it says, well, that's probably an integer, right? But I can also say long underscore val right here, which is the name of the variable, and assign it this and put an L at the end to explicitly say that's going to be a long variable. I could set it equal to 2.0, which would mean that it's a float. I can also set it to the keyword true or the keyword false with a capital F, and it will infer it as a Boolean type value. So I'm going to do a few print statements here. Now, one of the things that you'll notice in here is these print statements are actually written in Python 2 syntax. However, if you look at some of the Jupyter Notebook examples, all of these examples you'll see inside of one of the Jupyter Notebooks called Python Intro. And all of these examples have been rewritten in Python 3, so you can see the exact changes in syntax that occur for those. However, in most of the examples, it's simple. We just need to add a parentheses around what we're printing, and that's all. Good to go. So if we print out the variable types, I can actually use the function type and then give the variable into the type function and print out the type of each of these variables. We would expect it to be int, long, float, and Boolean. I can also test for the type of the variable that it is using the isInstance function. All of these are batteries included functions built into Python. Immediately you get access to these functions. So when I say isInstance float val of type float, float right here is a keyword, right? So it understands that float is some type. It understands that int is some type. So we would expect isInstance float val to return true and this to return false. And if we run all of these, what we would see on the terminal output is, yeah, these are of type int, long, float, bool. IsInstance float val, it is a float, it is not an integer. Okay. So those are a really quick overview of some of the types of variables that we have. Let's talk about how to do some of the arithmetic and casting that's part of Python. And again, these are Python 2 examples. So the arithmetic examples that I give right here, I can explicitly divide 8 by 3. And when I do that in Python 2, it's going to interpret these as both integers, and it's going to try to return an integer. In Python 3, that's not the case. So if we look at some of these outputs that we have right here, in Python 2, 8 divided by 3 would be equal to 2, because it's an integer divided by an integer. It's, the actual float value is 2.66 if I were to cast these correctly. In Python 2, it tries to return an integer and it just floors the value of that. So it takes it down from whatever it is to an integer value. So it's 2.6, it converts it to 2. In Python 3, it will actually do all of this casting for you. I can also do some logical assignment here. So I could print the value of, hey, what is true and false together? So true and false is actually false. I would need true and true for it to be equal to true. But you'll notice I can do these logical assignment with the value of and right here, right? So in other programming languages, you might see a ampersand where they say and right there. In Python, you're actually just going to put the keyword and or not. You're actually going to write it out, and that makes very, very readable code. I could also do logical equality, 8 equals 3, 5 less than or equal to 6, right? And I can see what the outputs look like. For multiplication, we just use the 2 times 4 can be interpreted this way. 65 modulus 6, we can see that it goes into, we have a remainder of 5, which is the modulus operator that we have right here. And then also, if I want to take something to a power, I can use the times operator, right? So 3 and then 2 asterisk 4 means 3 to the 4th power. We can see 3 to the 4th power is equal to 81. Right? So this is basic arithmetic. This will get you through most of the numerical operations that you need to do in any programming language. Very basic. So let's talk about some of the string operations that we have. Now, Python doesn't really care if you put a string in double or single quotes. It's always going to interpret that variable as a string. So if I were to say str_val, I could give it these single quotes or double quotes right here, and it'll interpret this as a string, right? So let's print out the outputs of all of these, right? And it'll say a string is a double or single quotes. I can also have a long string that I actually expand over multiple lines. So in this example, I actually give 3 single quote operators in a row, and that tells me that I'm going to have a string, I'm going to new line at the end of that string, right? So in this string, it actually saves the new line at the end of the word over right here. So at the over right here, I actually have a /n, a new line operator right here. And so it saves that into the variable. So if I were to look into this variable, it's got that new line. If I want to avoid that new line, I can actually just put a little escape operator right here. So I put the slash in here, \, and this actually has no new line in it. It's just I'm defining this also spans multiple lines but has no new line string. I'm just spanning it into multiple lines for readability. So I put this \, operator there to say, hey, don't save the new line at the end of this operator. And then when I print it out, it actually just prints out the whole string without the new line operator, whereas this actually printed out the string with a new line operation. Okay, so let's talk about some other string operations. Strings are going to be much like vectors in any other programming language, or arrays if you've seen in other programming languages. So let's print out some operations that we can do here. Now, if you've ever used R or MATLAB style syntax, you're going to be very familiar with how to use strings in Python. So the string value, which we had defined before, if we print out the first element, well, that's just the 0th element of the string value. However, we could also print elements 3 and 4, but not 5, and we can give it this operator, which means, hey, print from 3 all the way up to 5, but not including the 5th character inside of this string. So let's look at some of these outputs that we have right here. And if you originally this string value said a string is double or single quotes. So if I say string value with a 0, it's the letter A. From 3 to 5, it's TR, which is this TR value right here. You'll notice so 0, 1, 2, 3, 4, TR. String value at the -1 is actually interpreted as go grab the very last character of this string, which happens to be an S, so I print out an S. I can also say, hey, string value -5 all the way to the end, right? So it goes, go to the 5th element back and print out everything from the 5th element all the way to the end of the string, right? So it's a very convenient way of it going into a string. And what that does is it prints out the last 5 characters of quotes. And they've built these operators such that if I were to say, string value from 0 to 5 plus string value from 5 to here, plus for strings is a concatenation operator, then I'm actually going to print out string value from 0 to 5 and string value from 5, 0. That actually gives me back the original string that I had, which is kind of an interesting. Now, this right here is string value at the 5. Strings are immutable. What that means is once you've set a string value, you can't change the characters, the individual characters in the string. You can overwrite the string completely with a new variable, but you can't just update the string variables. So this right here would actually give me an error if I tried to do a character assignment inside of that string. Okay, so let's go through some more common string operations. We saw that the plus operator was concatenating strings, and that's a pretty typical. But we can also do this string value times 2. And that's interpreted very, very literally as string value plus string value, right? So if I were to say string value times 2, I would get a string as double or single quotes, a string as double or single. I would just concatenate it twice. If I said string value times 3, it would concatenate it 3 times together. I can also do greater than or less than, and it'll actually do a straight ASCII comparison of some of the characters, right? So it says it'll go character by character, and it says, oh, if these are different, well, is the first character greater than or less than? So it's like an alphabetizing method where I'm alphabetizing, but it's cognizant of the case of the character. So P is greater than J, so Python greater than Java is actually returns true. I can do lots of, strings are actual variables. They're class variables. So a string is a type of class. So I can actually perform functions on that class using dot notation in the very same way as Java. So if I were to say Eric right here, dot capitalize, it would capitalize the string Eric. If I were to say strval dot lower, it would make sure everything is lowercase. Dot upper would make sure everything is uppercase inside of the string. Right? And there are many, many different string operations functions, many convenience functions that are built into Python, batteries included string operations. So if I create this variable right here, this is separated by commas and then called dot split. Well, what that'll do is actually return to me something called a Python list, which we'll talk about in a moment. And it goes through the string and it separates everything that I had, a comma here, and it becomes separate strings inside of a Python list. We'll talk about lists in just a moment, but now that we know a little bit about strings, let's actually go through and do a very quick example with a calculator, right? So what we're going to do here is, what we want to do is we want to build a calculator eventually that we can enter numbers and we can enter plus signs and subtraction signs and multiplication, division, and actually go through and build up something that will interpret all of the string variables that we give it, all of the floats, and all of the operators, and actually just do calculations, very much like a graphing calculator that you might have. Right? So let's very quickly go over and let's go here and we'll look at how to build a calculator example. So what I'm going to do here is we're going to use the terminal for our input method. Right? So what I'm going to do here is I'm going to write some Python code, and you'll see this calculator example1.py. I've just added that into our notebooks directory. So I'm actually inside of the notebooks directory right here. So when I call ls star.py, I actually get calculator example1.py right here. So what I want to do here is get the calculator example, and we'll write it from a file right here. So I'm writing everything, all the code, in a file. The first thing we'll do is we're just going to print a prompt, right? So I'm going to print. This is the we'll call it the calculator prompt, right here. Right? And now what I'm going to do is I'm going to set some variable. We'll say var1, right? Is equal to, and now I'm going to use something called input, which is exactly like a cin or an input from Java, right? Where I'm just going to say input, open parentheses, and I'm not going to actually say anything inside of the input prompt, but basically I'm going to call input here, and whatever the user inputs from the terminal, it's going to save inside of variable 1, and it'll save at default as a string, right? So I haven't done any conversions. So now what I can do is just print var1 right here. Excuse me. So I've saved this, and now what I can do is I can say Python, and we will run this calculator example1.py. So if I run this calculator prompt, now it's waiting for user input. So if I were to enter something like test right here and hit enter, then it takes that as input, saves it into variable 1, and prints it back out to the console. If I were to do the exact same thing with, say, oh, we're going to enter 45.0, it would print out 45.0. Whatever I put in, it's just going to put right back out onto the example. Now, while it's great to be able to do this from a file and add some code and then be able to debug it over here, really what I'm going to want to do here is I'd like to do this calculator example inside of a Jupyter notebook. So rather than creating the file and running it, I'd rather just create a cell of the code and run it. And that way, every time I make additions to the code, I can create a new cell and run it from there. And that creates kind of an archive. That's a really nice example format so that you'll be able to follow along with this is where we started from, and we added code to do this, and see the output at each step, right? So let's do that. Let's actually go in here to create a Jupyter notebook, right? And we will we'll call it the calculator example right here. So I've actually already got this open right here. And so I can go ahead and close it down. We'll reopen it here, but you'll go in here to this 1 and 2 calculator sandbox.ipython notebook. And this is going to contain all of the examples that we want to do for running this calculator. So there's a couple of things that I will do here. First of all, I'm running from Python 3 right here. And what I can see here is that I've got I'm going to do some imports right here. You don't really have to know what some of these are, but if I run these, what it just tells you is that I'm running Python 3.5.2. It's kind of like a watermark. at the top of the Jupyter Notebook so you'll know exactly what my system was when I was running this example. So I'm running Python 3.5, and if you're running Python 2 and you run this example, it'll still work. And the reason that it'll, or at least the print functions will still work, because I'm going to import the print function from the future, right? So if you're using Python 2, it basically grabs the print function from Python 3 and makes it so that you can use it in Python 2. I would still recommend running this from Python 3, however. So now what we're going to do is we're going to repeat the example that we just did, right here. So I've created a cell of code right here, and it says print calculator prompt, and then user input is equal to this input function, exactly the same type of thing that we wrote before from file. So I can run this using this little tab right here. So we'll go ahead and run it right there. And you'll see it's now expecting user input right here. So if I enter 45, it prints out 45, exactly as we had. Okay, so let's do something here where we actually want to print out not just what the value of this is, but let's see what type of variable it's saving from this input function. Okay, so essentially what we'll do here is I'm going to define a function, and we'll talk about how to define functions very quickly, but since this is so simple, I figured it was easy to throw in here. We will, I'm going to use the def keyword, and I'm going to say, hey, define convert user input value, right? So the input is value. I don't care what type of variable it is. All I'm going to do is return it. Okay, so this is a very, it's a function that eventually will do something, but right now all it does is going to return the input value that we have right here. Very, very simple way to start with functions in Python. So now what I'll say is, okay, I want to print calculator prompt. And now I'm going to say, okay, user input is equal to convert user input, which is the function that we just wrote, we just defined up here. And now I'm going to do input right here. So it's going to call this input function. The output of that input function, it will put into convert user input. And it will save the output, so it's just going to take that in and return it, and it'll save it into user underscore input. Now when I print this out, I'm going to print out two things. I'm going to print out user input, and I'm also going to print out the type of user input that I have right here. So I'm going to run this block of code. To do it on my machine, I'm just going to hit Shift-Enter, right, rather than hitting the little run button. Okay, so if I put Eric right here, I can see that it's of type class string. Great. So let's run this again, and let's enter a number this time. So I'll say 45.0. Oh, it's still of class string. So you can see that this input function, it's not doing any type of conversion. So if we're wanting to save the user inputs as floats or integers, things that we can do numerical operations with in a calculator, we're going to need to change that around. We're going to need this convert user input function to actually convert it to be something. So if I enter 45, I want to save it as a float value. If I enter a plus sign, I want to save that as a plus string, or an operator that I know what to do with. Okay, so that's what we'll talk about, but in order to do that, we need to talk a little bit about using Python lists, and we need to talk a little bit more about some of the basic syntax that's in Python.